Doc, welcome back. It's now 7:48 p.m. Eastern time. We just took a few minutes break. I appreciate the extended time, sir.
You're welcome. Always.
So, part one was a lot of math. Part two was a little fun with some movies to CYAS, keeping it keeping it for kids.
Yep.
Uh, um, I'm gonna let you drive. Ask, tell. This is all yours, there, Doc. So, you're a brilliant man, and I appreciate making your acquaintance, which I still think is less than 3 months ago.
Yeah,
And,
yeah.
and
It's not been long.
no,
Not been long at all.
we have never met. There's no possible. We've done the math. There's no possible way we have met. And other than collaborating verbally, really, a couple, maybe a handful, 10 times stop, something like that.
Yeah.
Uh, you're a busy man. I'm a busy man, and I'm just retired. So,
My wife thinks I am too. Yeah.
lazy. They don't know how much goes on in the background. So with that, Doc, you drive.
All right, thank you. So I'd like to say that there's a way in which we can bring two sides of the coin together, a way in which we can look through a pinhole camera and see the image on the inside rather than on the outside. So the lens in which I want to share, or the vision of the future, which hopefully will be revealed, is one that allows us to relook at biology in terms of the orientation of the human retina and looking in rather than out. And if we just pause for a moment to think about the darkness, and then to shed light, to turn the light on. The moment that that switch gets turned on is a pretty big change in somebody's vision system. The way that the lights get turned on within and the way that the light is turned on in the sun appears to be one and the same. And the starlight within is something that people haven't really unlocked. They haven't really been taught how to unlock their starlight within. And so what I'd like to share really is a new way scientifically of looking at starlight, a new way of looking at the structure of atoms as a way of seeing the stored starlight within them. And if we are inclined to use a different way of looking at atomic structure, then we can reorientate our understanding of the universe that we're seeing not being outside of us, but being inside of us, and a way of reorientating our life in order to find balance, to find the point within. And to do that, I was a regenerative medicine scientist that had a profound experience. And that profound experience allowed me to look at the quark numbering, or the charges that are used in physics for quarks and neutrons and protons. And rather than using the fractions and adding to get the +1 charge for a proton and a 0 charge for a neutron, I decided to have a look at an alternative numbering. And what I propose is that for biology, we have to have a numbering system that's consistent with positron and electrons. So therefore, the quarks have to either have a +1 or a -1. And by doing that, we can really kind of explore addition, multiplication, division, and subtraction. We can explore all the different ways of trying to look at quark charges rather than just basing the quarks on the fractional charges and adding them together. So when I looked using multiplication and using whole numbers, I got to see that, well, a neutron in this new way of looking at quark charges actually have an overall charge of -1. And if you think of the proton being +1 and the neutron being -1, all of a sudden, well, opposite charges attract. The neutron and the proton could be attracted to one another because of the opposite charges that they held. And when I looked at that, I thought, well, the standard model of physics has an overall charge of 0 for a neutron. And so this neutron of 0, and I've got a neutron of -1. If I put a positron into the model, then all of a sudden I could make my neutron also have an overall charge of 0. So I added positrons in there, and then I looked at the mass of the neutron, and I thought, hold on a second, the mass of the neutron's bigger than the proton? And because the proton and the neutron both have 3 quarks, and they can be interchanged through beta plus and beta minus decay, and my quarks go from up to down or down to up, I thought, well, that could explain why the mass of the neutron is bigger than the proton, because there's a positron present in every neutron that's been measured. And if we look at the idea of the pinhole camera and the mirrored symmetry of opposites and the center of the atom of the nucleus acting kind of like a pinhole, which inverts this side of the atom and that side of the atom, and if I have a proton and a neutron that are balanced, +1 -1, like the electron-positron pair +1 -1, all of a sudden the model is different from the standard model. And I call it a supersymmetry inversion model. And that inverted symmetry is aligned with the human retina looking inward. And so this new paradigm shifting concept of mirrored symmetry, or the balance of opposites, is a very kind of, I guess, yin-yang type idea, but it also is founded in solid matter physics of proton, neutron, electron, positron. So, and there's the 3 quarks in the neutron and the 3 quarks in the proton, and they can change. Basically, if there's not a mirrored symmetry, there's not a balanced state, and I've got an uneven number of neutrons and protons, and if I have that, then I have an isotope, and isotopes decay, and they decay into a balanced state of I have an even number and an equal number of a neutron matching a proton, an electron matching a positron. And from that geometry, I was going, that makes more sense to me. That makes more sense.
How did color come into it for you?
I would say that I started with that as a framework, right? It's a foundational framework. And because I was then going, well, how do I apply that foundational framework to a cosmological universe? And how can I look using that framework at how the universe started? And so I started looking at, well, if I have 2 additional particles per atom of helium, and helium's the only atom of the universe that is still liquid at absolute 0, I got a different concept of the beginning not being from the Big Bang, but this kind of super cool atom of helium. And so then I kind of stepped away from that, thinking, well, that aligns my model to what I believe to be, based on cosmology, the three fundamental things that are present: matter, dark energy, and dark matter. And that alignment was shown to be successful.
Just like Newton, right? For every action there has to be an equal and opposite.
Yeah. So because it returns that every action has an equal and opposite reaction, the idea that there was this inflationary phase means that there was also an implosive opposite energy system operating at the same time, which was a gravitational process. So both outward and inward, and they mirror each other in terms of their energy, so that the overall energy between the out and the in is cancelled out. So there's essentially no change.
Yep. So is it fair to say black holes don't stop, Doc?
No, I'd say they act more like a pinhole camera. And if you have alpha particle emission from the black hole emitting energy at speeds faster than the speed of light, then what you can see is the way of decay.
Gotta throw the flag, Doc.
Yep.
We've been taught, ever since I was capable of understanding,
yep,
the speed is 186,000 miles per second.
Yes, I know, and I was taught that too. If you think about atomic decay from the singularity, like a black hole within an atom, if there's insufficient velocity, you can't escape. You've got no escape velocity. So you're kind of housed in the concept that light's the fastest thing in the universe, and therefore you cannot have an expansionary universe. The universe in this supersymmetry model that I've developed, and it goes back into the helium atom and understanding this helium Bose-Einstein condensate geometry, the distance between the particles is 4e to the negative 14 meters, or 0.1234 zeros and a 4 nanometers.
Yeah. So, I just to keep this down to earth.
Yep.
You and I went through a method called EMDR and MTAP.
Yep.
Just two valid scientific methods for PTS.
Yep.
And I think our very first interview, we talked about a door slamming generally between the ages of 2 and 4 year olds is what seeds a future trauma that triggers a release. Are you saying possibly that the folks that have actually gone through PTS might have a little, albeit confusing, but path?
I say that there is a way that the mind stores that trauma that hides it away, right? And
closes the door.
Yeah, it closes the door, it locks it. And if you think about inhibitory neurotransmitter coordination chemistry, there's fundamental biochemistry that can explain that, right? So
how much of the world issues could we solve right now, right today, with knowing there's a method to
release the trauma,
to release and let it go?
Yeah.
And starting with a door slam, an argument, something that was relevant to a infant to 2 to 4 year old.
Yeah.
Please go. I told you the floor is yours.
Yeah. The way that memory is locked can be undone. It can then be released. And so that release process, if that memory has been held down for a long time, it is a lot of energy released at once, and that's an energy that can be used by the body in order to heal that PTSD, that trauma parts.
It can be a scary road.
Yeah, it's a really hard road, right? It's not easy to release it all at once, to kind of give it back. You've been told to hold it in, to suppress it, to keep it down, to kind of, hide it away.
Yeah, I'm a past commander in a lovely little post 91 in Chandler, Arizona, that I commanded for 2 years. We had some family issues and just stuff happened. New CEOs, change of guard, and a lot of stuff. But I used to hear from these guys. I met the last of the 99th frogmen, and it's something you just see in their eyes, and it. See it.
So there's a profound way now that we can understand those processes, not using the current framework, right? So we're not using a framework of an atom that has a neutron, a proton, and an electron. We've got a new model that includes positrons, and what really that allows you to do is to shift from this external concept of measured atomic structure into an atomic light based electromagnetic structure. So you talked about or asked about how I saw color, and in terms of that, I went, I guess, really back to the idea that the photoelectric effect, or the movement of an electron from one orbital layer to another in hydrogen, was corresponding to a spectral line color. And that for me meant, well, I had to look at the electromagnetic properties of hydrogen in terms of its orbital layers and correlate that to the spectrum of electromagnetism, where vision occurs in between UV, high energy, infrared, low energy. So vision is housed in between the N=1 layer of hydrogen, UV, and N=3 layer of hydrogen, infrared.
So just some quick math off the top of my head, and following Snell's law, your math would only work if you accounted for all the particles in the universe. Is that accurate, or help me? That was just some quick thinking.
Yes, I have included positrons, so I was able to take that back to the original helium Bose-Einstein condensate framework, which then gives the geometry distance apart of those particles, which correlate to an energy release in that decay process. And that process gave the inflationary process, so it allowed me to identify what dark energy and dark matter were, that composition to begin with, after that helium Bose-Einstein condensate.
So does the -1 get closer or farther from the atom? The neutron proton.
Right.
As it would that go to 2, N3, N4 and beyond, or?
I explain it in terms of, if we look at just one atom of that helium Bose-Einstein condensate to begin with, and we can go, well, what was one atom of helium actually look like? We'll just put it in a box in isolation for a start. It's got 16 parts to it, right? And the way why I say 16 is, if we think about the neutron having the 3 quarks and a proton having the 3 quarks, and there are 2 neutrons and 2 protons, so 4 times 3 is 12. And with the 2 electrons, that's 13, 14, 2 positrons, 15, 16. So in the collective single atom concept of helium in this Bose-Einstein condensate, there are 16 what I think is fundamental kind of particles. They're actually not a particle yet, right? They're actually this energy at the lowest energy state. And they have a distance apart corresponding to a particular distance that gives an energy when released that is corresponding. If you convert that into a kilojoules per mole, it aligns to a meters per second velocity. So why kilojoules per mole? I looked at that, and the reason why I looked at that was a little bit weird, right? I wanted to know something that was biologically relevant. So the model wasn't for understanding the universe. The model was for understanding biology through a mirrored symmetry lens. So it was a way of trying to understand, why do we have a system operating within single atoms that has balance, that has a dualistic perspective of negative and positive? And then the center of the negative and positive, that little point in the center of the two opposites, having zero mass, zero charge, zero space, zero time, and the idea of that singularity. And then can we use the singularity lens to look back in time? So the Planck lens lets you look back in time. And so all of a sudden it's like you're not operating using measurement, but you're operating using a foundational framework of logic. And you're trying to use the tools, the fundamental forces in the universe as the parameters that you're navigating how the universe operates, right? So it's a way of kind of going, well, I'm not actually using a -1 on a neutron or a +1 on a proton. I have to actually understand that, where did they come from? What were they before they were a neutron and a proton? They were the 3 quarks. And then what were they before they were 3 quarks? You know, we know about the 3 quarks, we know about the gluons, we know about the hadrons, the mesons, all those kind of things, right? So you have to unfold the process that's responsible for creating those things.
So just to talk some real science, for Chicago is getting ready in about 3 years, but it's active now to a certain degree, of beaming 800,000 tons of neutrinos through the Earth's crust from Chicago to South Dakota with monitors to do that. Can you kind of relate just how that interrelationship? I don't want to get too complicated, but just to let people know, not only is their data stored in CERN that'll take 4 years to get to where we're talking about, but the upcoming experiment of beaming through what should be impossible, the crust of the Earth, right? The impenetrable. How do you resolve that, Doc?
It's the science model I've developed takes the concepts of Dirac, of the very, very small, right? It's all the way down at the Planck scale, and it understands the origin of the Planck scale, not from the moment just after the concept of the Big Bang, right? It allows you to see the time sequentially that's taken 13.8 billion years for that inward implosive process of the 4 from the beginning to go down to the singularity. So it is like the hourglass that you're holding. And if you think of the hourglass as within the structure of that single atom, and 4 have gone down together to that point. The lens of that point allows you to go back 13.8 billion years ago to understand the structure that was there to begin with. And so we needn't use a framework of high energy physics. The actual Planck length itself provides context for the implosive gravitational system operating in the universe in balance with the outward trajectory of the inflationary process.
Compensated for lens.
What was that, sorry?
Compensating for lensing.
Yeah, indeed. And then you relate that back to hydrogen in our own biology and the implosive process from the infrared falling 3 times in the atomic layers of hydrogen.
So, folks, this is the What If Show. I'm Stitch, and we're sponsored. Black Hole Decisions is my company, and we're sponsored by D Community and Buckethead. And I want to thank you for joining us this evening. And Doc, we'll see you in just a bit.
Thanks, Randy. See ya.